Hi everyone. So in this video we are going to study about feedback topologies. So what did we study in the previous lecture? What did we study? At output there is always sampling, at input there is always mixing. Output will be sampled and will be mixed with the input. And in shunt connection, if there is shunt connection, that means voltage will be sampled and current will be mixed. And if there is series connection, that means current will be sampled and voltage will be mixed. So this was the conclusion, that 3 points were there. So this is what we studied in the previous lecture. Now using that thing, now we are going to study feedback topology. It will be very easy for you. Just put your concentration for next 2.5 hours. Nearly it will take 2.5 hours. You will be understanding a lot of new things in feedback topology. Okay, it will be very interesting. You just need to put your concentration. So the first feedback topology is voltage feedback topology. What do you understand by that? That voltage means from output voltage is sampled and fed back to the input. Let's take this. From here voltage will be sampled. Now it will be converted into voltage only and will be fed back to the input. So voltage is sampled and voltage is mixed. That's why it is known as voltage sampling. Voltage is sampled and voltage is mixed. But we always write in the previous order. No, I shouldn't say previous order. We write in the opposite order. From output to input we write. So from output voltage is sampled and fed back to the input and it is mixed. From output voltage is sampled and fed back to the input and it is mixed. So always we write in opposite order. But if we are writing in series shunt, if we are writing in this manner, series shunt or shunt series or series or shunt, then we will write input and output. Then we are going to write input and output. How this name is written? Look, voltage is being sampled and voltage is mixed. If voltage is getting mixed at input, what is happening? Voltage is getting mixed. If voltage is getting mixed, that means which connection is that? Voltage is mixed in series connection. So that's why it is written series here. These are just the name. When we draw the diagram, it will be more clear to you. Now this is one more name, and this is also written as output and input. So there are basically three names. These three names shows the same thing, but they are written as output input. So if both are voltage current or current voltage, then it will be written in output input. If both are series and shunt, series shunt or series or shunt or series. So series or shunt is there, that means it is written in input and output. And one is voltage or current and one is shunt or series, that means it is written in the form of output and input. If it is not being cleared, hold on to the lecture, it will be clear to you. Just wait and watch. So first feedback topology is voltage topology, you can say series shunt or voltage series. Let's just make the diagram, it will be more clear to you. So we are talking about voltage feedback topology. So what do you understand by voltage feedback topology? That from output voltage is sensed, and fed back to the input or mixed with the input and fed back to the input. So basically voltage is sampled. So what is our output voltage? Our output voltage is V0. Now that will be fed back to the input. Output voltage is being sampled. That means which connection will be there? Output voltage is sampled. That means there has to be shunt connection, right? So this portion of output voltage should come as it is. So basically this node and this node should be connected. So this is what we are doing. This node and this node we are connecting. And now we are going to connect this lower node with this node, right? So this is the V node here we are getting. Now that will be multiplied with the feedback factor. Let's call it beta V. I'm calling this feedback factor as beta V, or I can call it beta as well. So what you will get, let's just call it beta only. What you will get here, beta V node. Now it will be fed back to the input. It will be mixed with the input. It will be mixed with the input voltage. So voltage is getting mixed. That means there should be series connection. So in series connection, this and this will be connected. but here we need to apply the input as well. So let's just apply the input first. In between we are going to apply the input. With the input voltage, this beta V naught is being mixed. So this beta V naught is being fed here. Basically this beta V naught is being fed here. So this node will be this positive. This positive node will be here and this negative node will be coming here. This is your beta V naught and this is your plus minus VE. Right? Are you getting this point? Tell me what will be the potential here. Use your brain and tell me what will be the potential here. Can I write down the equation? Let's just assume this potential is x. So can I write down that V in is equals to x plus beta V naught? Say yes or no. V in is equals to x plus beta V naught. This potential plus this potential is equals to V in. Because if this potential is 0, this potential will be V in. If this potential is 0, this potential will be V in. If this potential is 0, this potential will be beta V naught. If this potential is beta V naught, then this potential will be beta V naught plus x. So V in is equals to beta V naught plus x. Very easy, well and good, very straightforward. Simple network analysis is used. Right? Right. So what will be x? X will be V in minus beta V naught. So I am directly writing here, this is V in minus beta V naught. This potential is V in minus beta V naught into forward gain A. What will be the unit of A? Tell me what will be the unit of A? Volt per volt, because input is voltage, output is voltage. So unit is volt per volt. So from output voltage is coming, it is being multiplied with the feedback factor beta and will be fed back to the input. So if voltage is sampled, that means there has to be parallel connection, and voltage is mixed, that means there has to be series connection. So in the input side you are having series and in the output side you are having shunt. So I'm not going to show it in the diagram, but let's just show you as a rough way that this is your series connection, right? And this was your shunt connection. Well and good, understood? But better if we try to show it, the diagram will not be that much clear. Okay, it is clear only. I can show it in this diagram. So I can say this is your series connection. Why is it series though? Because if I in current is going here, that means if I in current is going here, the same I in current will be going here as well, and the same I in current will be fed to this, and the same I in current will be going out. I told you about series and parallel connection in the previous video only, right? And what about this? This is V naught. Simply V naught is coming. That's why it is parallel connection. The complete V naught is coming as it is. That's why it is parallel connection. So this was the series and this was shunt. Shunt. And what do I call it? Voltage sampling. Voltage sampling. And what do I call this one? Voltage mixing. Voltage sampling, voltage mixing. So how the names are written? Voltage sampling and voltage mixing, right? What about the other one? Shunt. Sorry, what about the other one? Series shunt, input output, and the other one is output to input. So this name is more famous actually. This name is more famous, but in the examination any name can come. This name can also come. This name can also come. But this voltage current, current voltage, and current current. This name is more famous. That from output voltage is sampled is fed back to the input as a voltage only. But any name can come, so you have to remember. And the last name is output to input. So basically voltage sampling and series connection. Voltage sampling and series connection. So voltage series. So this is also output to input, but here both are the different expression, voltage and series. Here voltage, that means they are the quantities only. Series, they are the connection. But here voltage series, quantity and the connection. This shows the quantity, this shows the connection. Right? So this is the scene. Let's talk about the next topology, that is voltage current topology. That is voltage current. So what will happen? Voltage will be sampled and will be fed back in the terms of current. Are you getting this point? Voltage will be sampled and will be fed back in terms of current. So the voltage will be coming, it will be turning out into current and will be fed back to the input. So what is being sampled? What is being sampled? Tell me, what is being sampled? Voltage is being sampled. and voltage is sampled in what? Shunt connection. So here you will write shunt, not at the input side. Here you will write shunt because I am going to write input output. At input, what is happening? Current is being mixed. From output, voltage is coming, that is converting into current, and it is being mixed with the input. So current is being mixed. If current is being mixed, in what connection current is mixed? Shunt connection. So this is known as shunt. And what can be the other name? The other name can be current shunt. You can think about it on your own. It would be current shunt. So let's draw the diagram for this one. Yeah. So this is shunt connection. So both should be in parallel. Both should be in parallel. So from output, the current would be coming. Let's just assume this is your output current, I out current. If I out current is going here, so I out current would be going out as well. So this current is coming, and there has to be shunt connection. So sorry. From output voltage is coming. Sorry. From output voltage is coming. Sorry for that. Voltage is coming. That's why I was thinking what is we are getting wrong here. From output voltage is coming, and it will be fed back to the input. It will be fed to the feedback factor. This voltage is fed to the feedback factor. This node will be V0 only. Now this V0 voltage will be converted into current. This V0 voltage will be converted into current. So what should I write here? Tell me. GM, right? Why I am writing GM here? Because transconductance will make transconductance into voltage will be current. So GM into V0 will be current. Are you getting this point? GM into V0 will be current. So that's why I am writing GM here. Now that will be converted into current. Now what will be the connection? Again the shunt connection will be there because current is getting mixed. So let's make the input first. So first we will make the input. Look here, what will I make? I will make current source I in. Look, I could have made a voltage source as well here, that I could make a voltage source V in and I will get I in current out of it. Both are same only, but I am making a current source that is having V in voltage across it. So you can assume it in any manner. I am making a current source, so current is getting out of it, right? So current is getting out of it, and there is a parallel connection. There is a parallel connection only. Let's check what is actually happening. Now from V0 you are generating some GM V0 current. GM V0 current. Why the direction is inward, why the direction is not outward, I will explain it. No issues. Now tell me from where this GM V0 current will be flowing. This GM V0 current will be flowing from here only, right? You can't say, sir, the current will go here as well. No. This is open circuit. This path is open circuit and that is a jumper wire. So that has no connection. So GM V0 will be flowing from this path only. So this is your GM V0 current. GM V0 current. This is your GM V0 current. Or you can call this current as I feedback. I feedback. So what is the current going in here? This current will be I in minus I feedback. Say yes or no. This current will be I in minus I feedback. If I in minus I feedback current is going in, what will be the current coming out? This current will be I in minus I feedback. Right? Now where this current will be going? This current will be going something like this, in this direction, because here the current will not go because that is open circuit path. So I in minus I feedback current will be going this path. I in I in minus I feedback. Now this is I in minus I feedback current, that current is coming here, and at this side I in current is going. So what do you understand? From here I feedback current would be coming, and that current is GMV naught. So GMV naught current was going in, GMV naught current has to go out. Now from here I in minus GMV naught current is coming, because I feedback is GMV naught current only. So from here what is the current coming? I in minus GMV naught. I in minus GMV naught. So I in minus GMV naught plus GMV naught would be I in current only. So this is the I in current only. Say yes or no. Are you able to understand the complete connections? What we are doing? Actually, the current connection is a bit typical, but it is understandable because we have already seen series and parallel connection. So what is happening? From output, voltage is coming, that is being multiplied with GM, that is converted into GMV naught. Now this current is GMV naught, right? That is being mixed with the input. So why I took the direction to be this? Why I took the direction to be outward? Because we are making a negative feedback system. You can make the positive feedback system as well. You can make positive feedback system as well, but there you have to take this direction. Now I am trying to make negative feedback system, because in negative feedback system what happens? Some input comes, and from the output, this was some output. From the output, some multiplying factor is there, and it is subtracted with the input. It is subtracted with the input, right? So I in minus I feedback should be there. If I had made this direction, if I had made the upward direction, what would be the input current? What would be the input current to the amplifier? To the amplifier, the current would have been I in plus IF. But I want to make it as a negative feedback. Just to show in the diagram, I made the current to be in the opposite direction. When we solve the circuit, when we see the circuit, it will be more clear to you. The direction can be anything. Feedback current direction can be anything. It could be inward as well. It could be outward as well. But here I made it inward so that I could say that I in current is going this way and I feedback current is going out. So to the input I am having I in minus I feedback current. So now this current I am having, so this current is generating V naught voltage. Current is generating V naught voltage. So what should I write here? I should write RM here. So in voltage current feedback, the amplifier is RM, right? Because output is voltage and input is current. So the amplifier has the unit of ohm, and this has the unit of Mahu. In the previous one, this has the unit of volt per volt, and this also has the unit of volt per volt, because voltage, it is being converted into voltage converted into voltage, so volt per volt. But in this case it is ohm. How will you remember it? You see the name voltage current feedback. What do you understand? That output will be voltage and input will be current. Output will be voltage, input will be current. So output is voltage, input is current. That means the gain should be ohm, because voltage by current is resistance, that shows the ohm. Say yes or no, right? So input side shows the shunt connection, this side also shows the shunt connection. Voltage is being shunted, voltage is being sampled, and it is mixed with the input current. Well and good, everything is crystal clear. Current direction is also clear. I in minus IF, the same current is going in, the same current would be going out. The same current is traveling here. GMV naught current is going in, GMV naught current is going out. So I in minus IF current, I in minus GMV naught current is going here, GMV naught current is coming from here. So this current should be I in. Well and good, everything is crystal clear. No issue with that. So this was the second type of feedback. Second type of feedback topology. What will be the third type? It will be current voltage. Current voltage. Now tell me its name. What will be its name? Current voltage. So current is being sampled and voltage is mixed. Current will be sampled, it will be converted into voltage, and that is mixed with the input. So current is sampled. In which connection current is sampled? That is series. Why I am changing the color of pen? It will be series connection. And in which connection the voltage is mixed? That is also series. So series. And what will be the other name? Other name would be voltage series. Can I draw the diagram? Certainly I can draw the diagram as well. So let's check. Here it is. Current voltage. So what is the other name? Other name is series. So both should be the series connections. You can show I out direction in any, I out direction can be anything. It could be outward as well, it could be inward as well, but I am showing inward. I out direction inward. So if I out direction is inward, from here I out current would be going out. If it is going out, it should be going in this direction. So feedback is getting I out current. That's why I showed it inward, because I know if this is getting I out current, then I out current would be going out of from here. If I out current is going out of from here, that means there should be I out current going into the forward gain. This is the forward gain, no? So I out current, and from here I out current would be going out. So this is the series connection. Now this current will be converted into voltage. So what should I write here? RM, right? This current will be converted into voltage. So current into resistance will be the voltage. So here you will get the voltage, and that voltage is RM into I out, and then there will be a parallel connection. Or better, I should make the voltage source here only. This is our voltage source V in. Output current is converted into voltage. Now what will be this? This will be RM into I out. RM into I out. What will be this potential? This potential will be V in minus, this potential will be V in minus RM into I out. Say yes or no? V in minus RM into I out. Now this voltage is converted into current. So what should I write here? Voltage is converted into current. So I should write GM here. So forward gain is GM here. So what is the unit of forward gain? That is mho. Right? What did I show in the previous one? I guess I showed ohm only. Why is it ohm? It is mho. Right? This is for the voltage current feedback. Here I am talking about current voltage feedback. So, and this will be ohm. Right? No issue there. Everything is crystal clear now. This feedback topology is very confusing to a lot of aspirants, but here we are understanding with very good patience and very good concentration as well. You have to put the full concentration, then only you will be able to understand. And don't take much stress. This is not that important. Okay, it is very rarely asked, even in the interview or even in the gate examination or even in any written test. Okay, it is rarely asked, but it is a very good concept. You will get a very good conceptual clarity, because even for the educators as well, this concept is not that clear. I have seen a lot of educators. We will solve brilliant question from it. I will tell you 2 to 3 methods to solve a particular problem using the feedback topology without using feedback topology. So your conceptual knowledge will be enhanced. That's for sure. So don't skip this topic. Understand it, and at the end of the lecture, your conceptual clarity will be much better than that you had previously, right? So this was your current voltage feedback. So current was being sampled and fed back towards the input. Now what will be the next one? Next one will be current. So next topology will be current. So what will be its name? Tell me. Current is being sampled. In which connection current is sampled? Series. But wait a minute. This is the output one. Series. And what about the input? In input, current is being mixed. Current is being mixed. That means current is mixed in shunt connection. So at the input side you will write shunt, at the output side you will write series. And what would be the other name? Other name would be current series. Current series. Because at the output side current is sampled, and at the input side you will have series connection, so current is mixed. So current series. So this is the other name. So this was the last topology. So this is the last topology we are having. So already I have made I in current, and you need to make series connection, right? At the input side, what was the name of this? Shunt series. The name was shunt series. So at the input side, so we will start from output. So from output, what is happening? That from output current is being sampled. Output current is being sampled. So in the output side, there is series connection. So how do you make the, in the output side there is series connection? Yeah. So how do you make the series connection? This is how you make the series connection. Now I will take this as output current. Why so? Because if this is output current, then sorry, opposite direction. I will take this as output current, because if this is output current, then this will also be output current, and I want feedback to take the current. You can take any direction, but for the better conceptual clarity, for better for what do we say, for better results, because we are going to find closed loop gain, we are going to find open closed loop input impedance, output impedance. So for better results, this is the notation that you should use. Now we are going to put it in shunt connection, because current should be mixed. For current mixing, we need to take shunt connection. I have to add up this with this, upper one with upper one, and this is with this one. Now this is the feedback current. What will be the feedback current? Feedback current would be beta I out. Why I am taking this direction? So that it is being subtracted here. So what will be this current? This current will be I in minus I feedback. What will be this current? This current will be I in minus I feedback. What will be this current? This current will be I in minus I feedback. What is I feedback? I feedback is beta I out. Beta I out. This beta I out current is going here. So what will be the current coming here? That current would be beta I out. So I in plus beta I out is equals to I in only. So everything, our notation, our direction is, everything is correct, right? And what is the unit of this? It will be ampere per ampere only. What will be the unit of this? It will be ampere per ampere only. So I in, from I out current, it is being, I out current is sampled and it is being converted into current only, and it is being mixed with the input. So I in minus IF, I in minus IF current is going out, going into the gain block, and you are getting I out current from there. Clear? Everything is clear? Now with that, we can start making block diagram as well. You can make the block diagrams as well. So just a rough block diagram. Basically, you had some output current. Okay, we will make the block diagram later on. Let's study one by one. Let's study all the topologies one by one. Later on, we can make the block diagram. So this is the first topology. So in the first topology, you had some output. You had some output that was being fed towards the input. That was being fed towards the input. So let's just call this was your output. It was being fed to the input with the factor of beta. With the factor of beta, right? It was from V naught, we were getting beta V naught, and it was fed back to input side. And you had an input coming as well. From here, your input was coming. Your input was coming V in, and from V in, you had subtracted beta V naught. V in, you had subtracted beta V naught, and that was fed to V in minus beta V naught was fed to forward gain. That was A. Was fed to forward gain. That was A, and from there you received your V out. Better I should make V out here. From forward gain, from here you received V out. So this was your control system. V naught, beta V naught, V in minus beta V naught multiplied with A, from there you are getting V out. So this is the same as this, complete is same as this, but we have to show it in two port networks because we are going to find input impedance, output impedance, everything we are going to find. So that's why I showed it in two port network, but as a control system, as a block diagram, you can show it in this manner as well. Say yes or no. Everything is crystal clear, everything is too much clear now, right? Let's move on to finding closed loop gain of this control, of this complete system. So here we have the complete system. This was our V. From output, it was sampled. This completely V naught was coming here. This was being converted into beta V naught. This was your beta V naught. And the input would have been V in minus beta V naught. So we have to find closed loop gain. What is the open loop gain? Open loop gain is A. Open loop gain is A. Because if there was no feedback, this would have been the gain. Open loop gain is A. What is the open loop input resistance? That is Rin, which is not shown here. We will show it in next analysis. So this is Rin. What is the output impedance? This is R0. That is there. We already know it is inside the block. So we are not showing it here because we don't need it as of now. So let's start. So we have to find closed loop gain. So V in minus beta V naught is the input. V in, yeah, what is our target to find now? Our target is to V in by V naught. Our target is to find V in by V naught. That is our target. Target is to find V in by V naught. So what is your closed loop gain? Closed loop gain. So your closed loop gain is V in by V naught. I will write it AV when there is a feedback. AV when there is a feedback. So what can I write? V in minus beta V naught into A is equals to V naught. If you solve it, what we will get? V naught by V in. That you can call AV with feedback, that will be equals to A upon 1 plus A beta. Now people will have one doubt. What is that doubt? That people will say, sir, across Rin, V in minus beta V naught was coming, and then it was amplified with the factor of A, and now you had some R naught as well here. Yeah, I know R naught will be there, but R naught will be very, very small. So I kind of ignored it. I ignored the R naught value. Okay. I just said that we will be taking assumption everywhere that R naught is very small. So why R naught is very small? Yeah. Why R naught is very small? This is the first question. Because this is a voltage amplifier. This is a voltage amplifier, right? What is this? This is a voltage amplifier. Voltage amplifier. And for voltage amplifier, what is the output impedance? Output impedance should be as low as possible. So R naught is very low already. So I kind of ignored that R naught value. R naught I took to be 0, and I am saying that complete AV that I am getting here, that will be completely fed to the output. So this is what I assumed. So V in minus beta V naught into A is equals to V naught. So that assumption I made. So this is the first derivation. This is the first result. So A upon 1 plus A beta, that we already know, because if you are connecting something in negative feedback, your gain will be open loop gain divided by 1 plus loop gain. Did I say it correctly? Yeah. Open loop gain divided by 1 plus loop gain. Is it 1 minus loop gain or 1 plus loop gain? 1 plus loop gain. Open loop gain divided by 1 plus loop gain, or 1 minus loop gain. Loop gain is minus A beta or A beta only. A beta only. Yeah. It was minus V by V test. Yeah. So open loop gain divided by 1 plus loop gain. Let's find the other expression, that is closed loop input impedance. Now you need to find closed loop input impedance. So basically you are going to need the input impedance now. So now you will show it here. What is your input impedance? This is your open loop input impedance, that is equals to Rin. Open loop input impedance is equals to Rin. So this is your open loop input impedance. The gain is A only here, right? So this is your V in, and from here there will be some I in. So what you need to find? You need to find closed loop input impedance. So input impedance after feedback, what that would be? V in by I in. So your target is to find V in by I in, right? If this current is I in, so the same current will be flowing here, right? The same I in current will be flowing here. This I in current will be flowing through Rin as well. So what drop it will be giving? The drop it will be giving would be I in into Rin. Say yes or no? The drop it will be giving would be I in into Rin. I in into Rin. Now In into Rin is the voltage drop that will be amplified with the factor of A. The voltage drop, voltage will be amplified with the factor of A. So what this voltage will be? A into In Rin. Say yes or no. Our target is to find V in by In. So this is what we are going to do now. We are moving in this direction only. So what did I so that the In current is flowing through Rin as well. So that the voltage drop it will give me In into Rin. So if In into Rin voltage drop is there, that is being amplified by the factor of A. So what is the output you are getting? A into In into Rin. Now this output will be coming here. This complete output will be coming here because this is a shunt connection. So here you are having A into In into Rin. Now this will be amplified with the factor of beta, right? Because this is the feedback factor. So what you will get here? A beta In into Rin. This will be A beta In into Rin. So what this potential will be? This potential will be the same because this node is positive and this node is negative. So this potential is A beta In into Rin. So basically from this diagram, what you can write? You can write V in is equals to In into Rin plus A beta In into Rin. Say yes or no. Look, my target is to find V in by In. That's it. I know my target. So I'm not going to introduce any other variable. What if I had wrote V naught here? So beta V naught would be coming here. Then I had to convert V naught into some In into Rin or that factor. So I can have only these kind of variable in V in R in A beta. So all these values I know. I am not going to introduce any other variable. So that I did not introduce here. So I know that In current is flowing, In into Rin is the drop that will be amplified with the factor of A. So A into In into Rin that will be fed to the feedback factor beta. So that will be amplified with the factor of beta. So A beta In into Rin. So now that basically here it is connection. Here it is connected in series connection only. So V in is equals to In into Rin plus A beta In into Rin. So V in by In is, what is your V in by In? V in by In. Or you can say Rin after feedback. That is Rin into 1 plus A beta. How will you remember this? Look, what we are studying voltage feedback topology. Voltage feedback topology means voltage amplifier, right? Voltage feedback topology. What is the forward gain? Forward gain is A, that is volt per volt. So that is voltage amplifier. In voltage amplifier, what is the input resistance? In voltage amplifier, input resistance should be as high as possible. So in feedback, the input resistance is increased. For a voltage amplifier, input resistance should be as high as possible, right? Now you are connecting a feedback. So why you are connecting the feedback? So that it becomes a better amplifier, right? Why am I dumb to connect a feedback there? Because I know my feedback will decrease the gain. So why I am connecting the feedback? So that it becomes a better amplifier. For better amplifier, what do you want? You want your Rin to be as high as possible. For voltage amplifier, your input resistance should be as high as possible. So that maximum voltage is coming across Rin. So Rin will be increased. Rin will be increased. So Rin will be increased with the factor of 1 plus A beta. Say yes or no. Are you getting this point or not? Well and good. Everything is crystal clear. No issue there. Everything is crystal clear. Right? So this is the input impedance. Let's talk about output impedance. Closed loop output impedance. So the same diagram. No, not the same diagram. If we are talking about closed loop output impedance, what we are talking about? We will apply Vx here and we will get some Ix from there. Right? So this is the output impedance we are talking about. So if we are calculating the output impedance, this input will be shorted. So this input will be gone. Input is shorted. Input is gone. Let's make the A here. So this Vx will be coming here as well. Now the same Vx will be coming here as well because both are connected in parallel. If same Vx is coming, so what this voltage will be? Beta Vx. Now what this voltage will be? Beta Vx. Tell me what will be this voltage? If I call this voltage as X, so X plus beta Vx is equals to 0. So x is minus beta Vx. This potential plus beta Vx is equals to 0 because complete line is shorted. This line is shorted. If this is 0, this is also 0. Completely it is equals to 0. So x is equals to minus beta Vx. So x is equals to minus beta Vx. So this potential will be minus beta Vx. Or how you can see? How you can see? That sir, this positive node is completely going here. And this negative node is completely going here. That means it is beta Vx in the opposite direction. Or I can write plus minus minus beta Vx. So I can write plus minus minus beta Vx and I will remove those. Did you understand this or not? Minus beta Vx. This positive node was going here, this negative node was going here. So in the opposite direction you are having beta Vx. So from positive to negative you are having minus beta Vx. Now this minus beta Vx will be multiplied with the factor of A. So what you will get? Directly you cannot write that your Vx would be equals to minus A into beta Vx. Then what is the point of output impedance? Because we are calculating the output impedance now. Na? So output impedance R0 has to come in action. So R0 will be coming in action. Now what will be this battery? This battery will be, here I am writing, this battery will be minus A beta Vx. Say yes or no. This battery will be minus A beta into Vx. Now one assumption we will make, that is this Ix current is flowing. Now this Ix current can go here as well and it can go here as well. But R0 value is so small that complete Ix will be flowing through R0 only. It will not go into feedback path. So this is the assumption we are going to make. Assumption is R0 is very small. So complete Ix will be flowing through R0, not in feedback path. So this is an assumption that complete Ix will be going here only. Well and good. So this is the complete Ix. So Ix will be taken into action here as well. Right. So now can you write down the expression of Ix? What will be the expression of Ix? The complete Ix current is flowing through R0. So what is the current in R0? Can you write it down? Vx minus of A beta Vx. This voltage drop is Vx. And what is this voltage drop? That is minus of A beta Vx. Vx minus of A beta Vx divided by R0 is equals to Ix. Say yes or no. Because what is my target? I need to find R0 after feedback. That is Vx by Ix. What did I do? I applied a Vx there. I get Ix out of it. And the same Vx is being fed to feedback factor as well. That is beta Vx. So at the input you are getting minus beta Vx. That will be amplified with the factor of A. So it would be minus A beta into Vx. Here you are having Vx. Here you are having minus A beta Vx. So Vx plus A beta Vx divided by R0 is equals to Ix. So Vx by Ix, what would be your ROF? Or you can call Vx by Ix. That would be R0 upon 1 plus A beta. How you can explain it logically? Tell me. How will you explain it logically? You can explain it in the way that, sir, I know that voltage amplifier has a lower output impedance. Voltage amplifier has a lower output impedance. Why so? Because you want more and more voltage across the load. So output impedance should be as low as possible. So voltage amplifier has lower output impedance. So if I am connecting in feedback, then output impedance will be more reduced. So output impedance is more reduced. So these are the three expressions. What about the gain? Gain is reduced by a factor of 1 plus A beta. Input impedance is increased by a factor of 1 plus A beta and output impedance is decreased by a factor of 1 plus A beta. Say yes or no. Let's see an example. So in the example, in the examination, what will be happening? This question will be written and they will ask you what kind of feedback topology is that. So you will have to determine it. What kind of feedback topology is that? First, let's determine the type of amplifier. How do I determine the type of amplifier? What do I do? I increase V0 value. If I increase V0 value, what happens? If I increase V0 value, if I increase this node, what will happen? This node would increase, right? Or forget about it. If I increase this node, what will happen? This node will decrease because that is a common source. If gate is being, if gate is increasing, that means drain would decrease. If drain is decreasing here, if this node is decreasing, right? Yeah. So if this node is decreasing, then what will happen to this node? This node will decrease. Clear? Now people will have a doubt, sir, why did not you do this? That sir, if this node increases, then this node will also increase, because from here to here there is 0 degree phase shift. What did I tell you? From here to here there is 180 degree phase shift. From here to here there is 0 degree phase shift, and from here to here there is 0 degree phase shift. This is what I have told you, right? So if I had done something like that, that if your V node is increasing, then this node is also increasing. If this node is increasing, that means this node is increasing. If this node is increasing, that means this node is increasing. If this node increases, that means this node should increase. So you are getting two different answers. Are you getting my point? Did you understand my point? In the first point, what did we do? We increased V node. If V node is increasing, that means this node will decrease, because that is common source. From gate to drain, there is always 180 degree phase shift. From gate to drain, there is 180 degree phase shift. So if this increases, this will decrease. If this decreases, that means this will increase. This will also decrease, because from gate to source there is no inversion. So if this is increasing, this is decreasing. So if I try to increase V node, my final V node is decreasing. So that means there is negative feedback. But some student got a doubt that, sir, if this node is increasing, then this node should increase. If this node is increasing, that means this node should increase. If this node is increasing, that means this node should also increase. So what is the wrong thing we are doing? I told you, when you are determining the feedback, what you need to do? You need to short circuit the input. If you have shorted the input, there is no use of this node increasing or decreasing, because this node is fixed at 0 voltage. If you have shorted the input, the node is fixed at 0 voltage. So you cannot even look at this node, right? Because I forgot to short circuit the input. That's why I was getting two results. Now if input is shorted, then this node is increasing, this node is decreasing. If this node is decreasing, then this node will finally decrease. That's it. Okay, so let's remove all the points and let's write down the final one. So what kind of feedback is that? Input will be shorted. So if I increase this, what will happen to this one? This will decrease. And if this is decreasing, that means this is again decreasing. So what does it show? It is in negative feedback. So this is the first question that can be asked, that the given amplifier is working in what kind of feedback? This is the first question they can ask from this particular circuit. They will give you this particular circuit and what kind of feedback is there. These kind of questions are asked in the interview as well. Very, very important. What kind of feedback is there? So there is negative feedback. This thing we got to know. Now they can ask the feedback topology as well. So what kind of feedback topology is there? So what you can see here is that, where is the feedback? Where is the feedback? This is your output. Now output is going towards the input side. So this output is going here, right? So output is being fed to the input. Now it will be mixed with the input, right? It will be mixed with the input and generate some other output. Say yes or no. This is your feedback. This is your feedback. V naught is going here. It is being mixed with the input. If it is mixed with the input, what it will do? It will generate GM V in minus V naught current. GM V in minus V naught current here. Now this GM V in minus V naught current will be generated. What will be this voltage? This voltage will be GM RD V in minus V naught. Say yes or no. This voltage will be GM RD V in minus V naught. Now this is GM RD V in minus V naught. So what will be this voltage? What will be your V naught? How you can determine it? Look, whatever the current here is, that current will be 0 ampere. Why so? Because this will drive 0 ampere current. So here the current will be 0 ampere only. So if the current is 0 ampere, that means VGS is 0. If VGS is 0, that means this potential and this potential is equal. If VGS is 0, that means this potential and this potential is equal. What did I say? What current is flowing here? 0 ampere. 0 ampere. 0 ampere current is flowing here. 0 ampere is current is flowing here. So that means VGS is 0. If VGS is 0, that means gate and source potential are equal. So you can put GMRD V in minus V naught is equals to V naught. If you solve it, V naught by V in would be GMRD upon 1 plus GMRD. So this is the first solution which you solved without the concept of feedback topology. You did not use any feedback topology here. Did you use any concept of feedback topology? You just said that, sir, V naught is coming, V in is coming, then you put the voltage there and then you are getting the final output. That's it. What kind of feedback topology is there? The voltage is being sampled and it is being mixed with the input. It is being mixed with the input voltage only. Voltage is sampled, it is being mixed with the input voltage only, in form of voltage only. So there is voltage feedback. There is voltage feedback. So what kind of feedback topology is there? So topology is voltage feedback. Now I can tell you one another method of determining the feedback topology. Look, if I am saying there is voltage sampling, what does that mean? Whatever the feedback factor is there, it can be whatever the feedback factor is there, whatever the feedback voltage you get, Vf will be equals to beta V naught. It can be If as well. If will be equals to what? If will be equals to Gm V naught. If there is voltage sampling, what do you mean by voltage sampling? That your feedback will be depending on output voltage. Your feedback will be depending on output voltage. In these two cases, there is voltage sampling, right? If there is voltage sampling, that means if you put V naught equals to 0, the feedback factor should become 0. That what I am saying, if you put V naught equals to 0, that means there will be no feedback going into the input. So in this question, if I put V naught equals to 0, if I put V naught grounded, then what will happen? This will also be grounded. So from output, there is nothing coming towards the input. Say yes or no. If you are checking the feedback topology, so at the output, you will always see about V naught. If you short circuit the V naught, is there any feedback coming? If you short circuit V naught, is there any feedback coming towards the input side? No. If I am short circuiting the V naught, there is no input coming, there is no feedback coming to the input side. That means there is voltage sampling. So there is voltage sampling. Now let's talk about the other point. Mixing. What kind of mixing is there? So for checking the mixing, you will always look at current. For checking the mixing, you will always look at current. So if this is V in, that means what will be I in? This will be I in. So now you will check if the current is being mixed or not. Now this is the I in. So this complete I in is going towards RD here, and now that will be coming towards output. So current is not being mixed. If current is being mixed, that means what should happen? This is your I in. Let's just say this is your I in. Then it should get two paths at least. If the current is getting two paths, then only current is mixing. No. But here there is no current mixing. If there is no current mixing, that means there is certainly voltage mixing. So now you can say there is voltage sampling and voltage mixing. Did you understand this point or not? I will write it down in a brief manner. How will I write it down? Shortcut to find feedback topology. What is the point 1? For sampling, always look at output, always look at voltage. Output voltage I should write. Always look at output voltage. If there is voltage sampling, then what will be happening? That Vf would be equals to beta V naught, or from V naught current can also be generated. So If will be equals to Gm V naught. That will be seeing in the next case, that If is equals to Gm V naught. So both can happen, right? feedback current can also be there. If we put V naught equals to 0 volt, then there should be no feedback that is coming towards the input side. Input towards the input side. If that is so, that means there is voltage sampling. There is voltage sampling. Otherwise, current sampling. Say yes or no. So if I am asked to determine the kind of feedback topology, so what I will do, I will put V naught equals to 0. Then I will see if there is any feedback coming. If there is some feedback coming, that means there will be current sampling. If there is no feedback coming, that means there is voltage sampling. That's it. So here there is voltage sampling. Now what about mixing? For mixing, always check the input current. Always check the input current. For mixing, always you need to check the input current. If current is being mixed, then there is current mixing. Otherwise, voltage mixing. So tell me, is there current being mixed? No, IN current is completely going there. So there is no current mixing here. So that means there is voltage mixing. So voltage is being sampled and voltage is being mixed. So this is the concept and this is the way of determining the feedback topology. This is the way and this is the concept. So now what we have determined? We have determined two things. Topology we have determined. There is negative feedback. This thing we have determined. What kind of feedback is there? There is negative feedback. This thing we have determined. We have also determined the gain as well, but there will be different method of determining the gain. So in the question, what did I ask you? I asked you these three questions that you need to find the Rx value, Ry value and V naught by Vin value. Now if this circuit is coming in front of you in the examination, okay, this is coming into the examination or in the interview, and my question is find Rx, Ry and V naught by Vin. Will you be thinking about feedback topology here? If this circuit I draw and I ask you what is your Rx, Ry, V naught by Vin, these three things I am asking you, will you be thinking about feedback topology? No, I'm pretty sure no one will think about feedback topology. You will be writing down the final answer. Even if I had been the student, I would be doing the same thing. So first we are going to solve without feedback topology and then we will solve with the concept of feedback topology. So let's just remove this thing from here because this was our final answer. I got distracted to the topic actually. So let's just remove this thing from here because we need to calculate it. So we will solve it by two methods. First one will be the general one. From what everyone would have solved. By the way, if this increases, then this would increase. If this is increasing, then this would. Wait a minute. If this is increasing, then this would decrease. Sorry. So that was. Yeah. If this is increasing, then this node would decrease and this would increase. So yeah. Now we are going to solve Rx, Ry and V naught by Vin. Now how a general student would have solved if he is not thinking about feedback topology, and in the examination I'm pretty sure no one is going to think about feedback topology, so he will be directly solving it. So let's just see how we will solve it directly. Okay, so I will copy this circuit. So I am writing method 1 without the concept of feedback topology. Let's solve it without the concept of feedback topology. Let's remove it off. Rx, Ry we can show later on. Let's just not remove Rx and Ry. Okay, so if this is V0, this is V0 coming here. I have already shown this derivation. So what will be this current? This current would be GM1 V in minus V0 in upward direction. Till now you guys must be comfortable with the small scale analysis. So GM1 V in minus V0. So here the drop will be in this direction. So what will be this potential? This potential would be GM1 RD V in minus V0. And since there is 0 ampere current here, there is 0 ampere current here in this loop. There is 0 ampere current. That means VGS value is 0. If VGS value is 0, that means gate and source potential are equal. So GM1 RD V in minus V0 is equals to V0. So what will be your V0 by V in? V0 by V in is GMRD upon 1 plus GMRD. So this was the first thing that we needed to determine. The second thing is you need to determine Rx. So what is your Rx? Your Rx is V in by I in. What is your I in? This is your I in. Your Rx is V in by I in. So if this is your I in, this I in will be going here as well, right? Yeah, and what about this VDD? VDD will be shorted because we are doing the small scale analysis. This VDD will be shorted. So this I in will be going upward as well, right? Your target is to find V in by I in. That's it. Okay then. So if this I in is going upward, what will be the drop here? The drop here would be I in into RD. Say yes or no. If this is I in into RD, if this drop is I in into RD, what will be this potential? This potential will also become I in into RD because gate and source voltage are same. In this diagram, gate and source voltage are same because there is no current here. So this will also become I in into RD, right? Now what you can say? GM1 into VGS. GM1 into VGS. What is VGS? GM1 into VSG. Actually, direction is this. If you are following the lecture from beginning, you would understand what I am writing. What will be I in current? I in current would be GM into from here to here in the upward direction because direction is this. So from source to gate, what will be the current? GM1 V in minus I in into RD, right? And that would be equals to I in only. Say yes or no. Our target is to find V in by I in. So what will happen? Your Rx that is equals to V in by I in. That would be equals to, so this GM by RD, GM1. Okay, let's just solve it. This is GM1 V in minus GM1 I in into RD. So equal GMRD upon GMRD plus 1 into I in into I in. So what would be your V in by I in? V in by I in would be, and that is equals to Rx, that would be 1 by GM1 divided by 1 plus GM1 RD. Right? This is your Rx. Now your next target is to find R0. So what will be your R0? So for R0 again I will have to copy this circuit. This is R0 or Ry you can say. So what you are going to do, you are going to apply some Vy potential here and get Iy current out of it, right? And if you are finding R0, that means your V in will be shorted. This your V in will be shorted. If this V in is gone. Now this same Vy potential will be coming here as well. If this same Vy potential is coming here, that means this drop would be, this current would be GM1 Vy, right? This is Vy, so this current would be GM1 Vy. So what will be the voltage drop? Voltage drop will be in this direction. What will be this potential? GM1 RD Vy. That is GM1 RD Vy. Now there is no current going here. There is 0 ampere current going here. So what will be your Iy? Iy will be the current flowing through M2. What is the current flowing through M2? That would be GM2 minus GMRD, GM1 RD Vy minus Vy. So this current is equals to minus of Iy. So minus of GM2 minus GM1 RD Vy minus Vy would be equals to Iy. Did you understand this point or not? Very simple thing we are doing. Just a simple MOS amplifiers we are using, nothing else. We initiated Vy, GM1 Vy. So what will be the drop? Minus GM1 RD into Vy. This drop is minus GM1 RD into Vy and this is Vy. So what will be the current in the downward direction? GM into VGS. GM2 into VGS. What is VGS? Minus GM1 RD Vy minus Vy. So that current would be GM2 minus GM1 RD Vy minus Vy. That is equals to minus of Iy because there is 0 ampere current going here. So the complete current will be flowing through M2 MOS. So that is equals to Iy. So what will be your Vy by Iy? That is your R naught or Iy. Sorry, that is your Ry. That is equals to, okay, better solve it. What you are getting here, GM2 is there, then GM1 RD plus 1 into Vy is equals to Iy. So what will be your Ry? That would be equals to Vy by Iy. That would be equals to 1 by GM2 divided by 1 plus GM1 RD. Right? Well and good. This was your Ry. So this is the solution of the particular question that was asked. But why did we study the feedback topology then? So now we are going to solve this particular question with the concept of feedback topology. Here we solved it without the concept of feedback topology. Let's solve it with the concept of feedback topology. With the concept of feedback topology. Now this circuit was there. So what all my conclusion was? What all the conclusion was? Conclusion was this was voltage feedback. Voltage feedback topology. So what is the scene for voltage feedback? What is the closed loop gain? This will be the gain V naught by V in. V naught by V in would be equals to closed loop gain only, no? Closed loop gain. Right? Why it will be equals to closed loop gain? Because feedback is there. Let's talk about open loop gain first. Let's talk about open loop gain. So what will be the open loop gain? So first we are talking about open loop gain. What is open loop gain? That is equals to A. In the diagram that we made, this A we are going to talk about. Open loop gain. Now what do you mean by open loop? Let's draw the diagram here once again. This was your V in. This was your gain A. This was your V naught. V naught was being fed and was multiplied with the factor beta. And this was beta V naught, right? And this potential was V in minus beta V naught. If I need to make it open loop, what I will do? The feedback that is coming, that should be equal to 0. If this value is 0, that means this is open loop. There is no feedback coming. If this value is 0, then what will happen? The complete V in will be going towards the gain A. V in minus 0 into A will be equal to V naught. So if I need to make it open loop, I need to make sure that there is no feedback. If there is no feedback, that means from output there should be nothing coming. So your V node should be equals to 0. So this node should be equals to 0. Then only it will be in open loop. Say yes or no. So I will break the loop here. I will break the loop. If I am breaking the loop, what I am going to do? I will keep this node as open-ended. Look, what I am going to do now. Now I am going to break the loop like this. This loop I am going to break. What is the value of beta here? Can you tell? Beta is 1 because V node is directly coming. So I am breaking the loop. If I am breaking the loop, I will keep this as grounded because I need to know that there should be zero voltage coming. So this I will keep grounded and this I will keep as it is, open-ended only. From V node it was going there, but it is not being fed there. That's it. So I am open circuiting it and this will be as it is and this node will be grounded. So this is the open loop. Are you getting this point? This will be the open loop. Did you understand my point here? What do I mean by open loop? V in was coming, beta V node was coming, V in minus beta V node was being fed. But I need the open loop there because I need to find open loop gain. Why do I need to find open loop gain? Because what will be my closed loop gain? Closed loop gain will be A upon 1 plus A beta. If I know the value of A, if I know the value of beta, I can directly write the gain. That's it. So my first target is to find A, right? So what I will do, I will break the loop now. If I am breaking the loop, now the question comes, what it should be? It should be shorted or open circuited? It should be open circuited. It should be short circuited because if this was open circuited, you wouldn't know what is the voltage coming here. But you want zero voltage to come here. Why you want zero voltage to come here? So that there is nothing being subtracted from V in. So V in is directly coming, it is being amplified with the factor of A and it will be equals to V naught. So you want this to be shorted. That's why I am shorting it. So I am breaking the loop and shorting it, right? So what will be your open loop diagram? So basically this will be your open loop diagram. So if I am going to find open loop gain only, so I will draw the open loop diagram now. So this is shorted. VDD is gone. Why so? Because we are doing the small signal analysis. This is your RD. This was your V in. I can make V in like this as well. This was your V in. This will be shorted, right? This will be shorted. This is connected like this. The other end is open circuited, V naught. If you make it short circuit, what will happen? V naught will go to 0. Then question doesn't make any sense, right? So here I will keep it open-ended and this VDD is also 1. Now I can tell all the values. What values I can tell? I can tell you this we are talking about open loop now. This is the open loop. This was your M1. This is your M2. So this is the open loop. How the loop is opened, we understand by this block diagram. By this block diagram, we got to know that if I want zero input, zero feedback factor, if I want something zero coming from the feedback, I don't want any feedback. If I don't want any feedback, I would need this node to be 0. If I need this node to be 0, this should be grounded. Say yes or no. Well and good. So what will be my V naught by V in open loop? V naught by V in, that is equals to V naught by V in open loop, that I am calling as A. What that value will be? If this is V in, so what is the current here? That is equals to GMV in. This current is GMV in. This current is GMV in. So what will be the potential here? That would be GMRDV in. So what you can say? GMRDV in is equals to V naught. So V naught by V in equals to GMRD. So your open loop gain A is GMRD. This is one thing we got to know, right? What else we know? What is the feedback factor? Feedback factor is 1. V naught is directly coming here. V naught is directly coming without being multiplied with any factor. So feedback factor is 1. So beta is 1. So A is GMRD, beta is 1. Right? A is GMRD and beta is 1. Now if you need to write closed loop gain for voltage feedback topology, for voltage feedback topology, in case of negative feedback, in case of negative feedback, first thing, what is the closed loop gain? Closed loop gain, what I write, AB after feedback, that is equals to A upon 1 plus A beta. What that value will be? What is the value of A? A is GMRD upon 1 plus, what is A? A is GMRD only. What is beta? Beta is 1. GMRD upon 1 plus GMRD. Say yes or no. Did you understand this point or not? When we solved it without thinking about feedback, then what was the gain we got? GMRD upon 1 plus GMRD. What is the gain we are having here again? That is also GMRD upon 1 plus GMRD. Did you understand this? What did I do here? First I made it open loop. Then I found the gain in open loop. What was the gain in open loop? That was GMRD. How did I make the open loop? I short circuited the gate side of M1 and I keep it open circuit the source side of M2. Then the open loop gain was GMRD. I know the feedback factor is, that is beta, that is equals to 1. So what is my closed loop gain? That is A upon 1 plus A beta, that is GMRD upon 1 plus GMRD. That's it. Now what is the input impedance here? If I write R in open loop, what is my R in open loop here? If you see from here, what do you see? 1 by GM, that's it. R in open loop is, from here you need to see R in or RX, sorry, RX open loop, that is equals to 1 by GM1. Say yes or no? So closed loop input impedance, closed loop input impedance, closed loop input impedance, that is equals to Rx, that we are showing it Rx, that would be Rx open loop into 1 plus A beta, right? Why is it so? Because this is a voltage feedback topology. If voltage feedback topology is there, that means it is a voltage amplifier. If it is a voltage amplifier, that means our voltage amplifier should have higher input impedance. So Rin into 1 plus A beta. That was 1 by GM1 into 1 plus A beta. What is the value of A beta? GMRD. Wait a second. GMRD, I forgot to write with GMRD. GM1. 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 Here also I'm going to write GM1. GM1. GM1RD. So this is the value of Rx that I am getting with the concept of feedback topology. What was the value I got previously? Oh, Rx value, there is some issue, wait a minute. There is some calculation issue, I guess. Yeah, this is in multiplication only, no? Wait a second. Yeah, so I got it wrong here actually. This was in multiplication only. So we can do the mistake in calculation, but if I have the concept clear, then I will not do the mistake. So here in the calculation we did the mistake, right? But then we got it verified. How? With this analysis. And what about closed loop output impedance? Closed loop output impedance. So that we need to find, but before that I need to find open loop output impedance. So what will be your open loop output impedance? You need to look the impedance from here. You can call it Ry open loop. So what will be your Ry open loop? Where can I write it? Here I can write Ry open loop. What it will be? What do you think? If I am calculating open loop output impedance, that means if I am calculating output impedance, that means Vin will be shorted. If Vin is shorted, this will be shorted. Then that means there is no current. If there is no current here, that means there will be no voltage drop here. If there is no voltage drop here, this node will be 0. So from V0 to ground, what do you see? 1 by Gm. That's it. Did you understand this point? If I am calculating this impedance here, this will be shorted. If this is shorted, VSG is gone. If VSG is gone, there is no current here. If there is no current here, this node will be shorted because 0 volt, that ground will be coming here. If there is the ground, so from V0 to ground, what do you see? 1 by Gm2. That's it. From V0 to ground, you see 1 by Gm2. So what is your Ry open loop? That is 1 by Gm2. Till now, you should be comfortable with all those kind of analysis. So from V0 to ground you see 1 by GM2. So what will be your closed loop output impedance? That would be your output impedance in open loop divided by 1 plus A beta. Divided by 1 plus A beta. Why divided by 1 plus A beta? Because this is a voltage amplifier, and in the voltage amplifier you need lower output impedance. So divided by 1 plus A beta. So what was the impedance you were getting? 1 by GM2 divided by 1 plus A beta. A beta value is GM1 RD. GM1 RD. That's it. This is how you solved it with the concept of feedback. And we got the same in the rigorous analysis as well, when we did the analysis without even thinking about the feedback. So here we did not think about the feedback, still we got the final answer because we have studied MOSFET amplifier in very good manner. Now we are going to study feedback topology in very good manner. So now I can answer all these things without even using the concept of MOS amplifier, because I know the concept of feedback topology. My gain will be A upon 1 plus A beta. Rx will be 1 by Gm into 1 plus Gm1 RD, or Ry will be 1 by Gm2 upon 1 plus Gm1 RD. Now you will say, sir, if this question is coming in our examination, we are directly going to solve it. So why do I need to understand this kind of analysis? You need to understand this kind of analysis because they are the IIT's professor. They can frame any question in any manner. They will frame the question such that you will have to use this kind of analysis. And in 2024, there was the question that was asked in this manner only, that you needed to use this analysis only. They asked the small signal voltage gain. Although that was very easy question, the voltage gain would have been 40 upon 41. So what did they give? They give the voltage topology amplifier. Okay, then they give the open loop gain. They give the open loop gain, and feedback factor was 1. So what would have been the closed loop gain? Closed loop gain would have been 40 upon 1 plus A upon 1 plus A beta. Feedback factor was 1. So A upon 1 plus A, 40 by 41. That was the answer. We will deal that question, but that was very easy actually. But they can frame a good question. They will give you an open loop gain. They will give you open loop input impedance. Then you will have to analyze what kind of feedback is that. Then you will understand, okay, this kind of feedback is, first thing is that is negative feedback. Okay, you have determined negative feedback. Then you will have to determine if this is the negative feedback, that means if this is the negative feedback, then what do you understand by that? Uh, if this is the negative feedback, then you will determine what kind of feedback topology is there. Then you will see it is voltage feedback topology. If that is voltage feedback topology, that means it is a voltage amplifier. And if they are asking Rin with feedback, so Rin with feedback voltage amplifier, okay, Rin should increase. So Rin into 1 plus A beta. Rin open loop into 1 plus A beta. So Rin open loop will be given there, A will be given there, beta will be given there. So by that you will be able to write down the final answer. So yeah, they can ask these kind of question in the examination. So you should be comfortable with everything. Here I am not teaching anything very complex. You are understanding everything here, right? Tell me in the comment section that I am understanding everything. Every single thing that you are teaching, I am going to understand that. Because this was very easy lecture. First we go to understand the different names of feedback topology. Then I told you what kind of feedback topology is there. Voltage is being sampled, voltage is being mixed. Then we saw that three different derivation. I also told you the method to remember the input impedance, output impedance, and the gain, right? And we are connected in negative feedback. Then we saw the example. This example is also working in negative feedback. Then we saw the topology, that is voltage feedback topology. Then I told you a shortcut method as well. When you are seeing the sampling, you always need to see the output voltage. If I short circuit the output voltage, is there any feedback path coming? No, there is no feedback path coming. That means there is voltage sampling. Otherwise, it is current sampling. If you need to see the mixing, you will always see the input current. If input current is being mixed, if input current is having two paths, that means there is current mixing. Otherwise, it is voltage mixing. So here there is voltage mixing. There is no input current that is being mixed in the two path. So input current is directly going there. So there is no current mixing. So there is voltage mixing. So voltage mixing and voltage sampling. So it is voltage feedback topology. Then we solved that particular problem without even using the concept of feedback topology. So it's very simple, very straightforward. Then we use the concept of feedback topology to determine the given parameters. So gain we need to determine, input impedance and output impedance. So what did we get to know here? That first I need to make it open loop. So in open loop, this node will be shorted and this node will be open circuited. You don't need to mug it up which node will be shorted, which node will be open circuited, because we are going to see three more different topologies. So there you will understand which node should be shorted, which node should be open circuited. Here you must have understood, because you don't want anything anything in the input. You don't want any voltage coming into the input. If you want zero voltage in the feedback, that means this should be shorted. On 0 voltage, this should be shorted, and this will be open circuited only, because there is no meaning if I put V0 equals to 0. So this will be open circuited only. This was our open loop diagram. So what was our open loop gain? Open loop gain was GM1 RD. What was our feedback factor? Feedback factor was 1 only, because here it was directly going there. So feedback factor was 1 only. What was our open loop input impedance? It was 1 by GM1 only. What was our output impedance? It was 1 by GM2 only, because this one node was going to ground. So it was 1 by GM2 only. Then we could write down the closed loop values as well. So closed loop gain would be A upon 1 plus A beta. Closed loop input impedance would be Rx upon Rx into 1 plus A beta, and output impedance would be Ry upon 1 plus A beta. So with that manner, we understood these kind of things. Well and good. In the next lecture, we are going to study about 3 different mode topologies. We will do the same kind of derivation. We will see the same kind of questions as well. Well and good. Okay, so let's meet in the next lecture. Thank you.